OpenMusic is a visual programming environment for composers. It is beginner-friendly, and if you have done any coding before or used tools like Max or Pure Data, you'll recognize many of the core ideas. It was developed by IRCAM in Paris, one of the world's leading research centers for music and technology, and it's free to download from their website. To get started, we'll first need to create a workspace. This is just a folder where the files for our project will be stored. Once we've done that, we can start building our first patch. This is essentially what we call a small program in OpenMusic. We can do this by right-clicking in the workspace and choosing New Patch. We'll give it a name by double-clicking on the text below the icon and then double-click the icon itself to open it. OpenMusic is a visual programming environment. This means that instead of writing code, we create programs by connecting boxes, like literal building blocks with lines or wires that carry data from one to the next. Classes are like data structures in traditional programming. They are containers for information, such as lists of numbers. In OpenMusic, many classes are designed specifically for musical elements, like notes, chords, chord sequences, and MIDI data. Functions, on the other hand, are used to transform this data. Let's see how this works. We'll start by choosing the chord class. When we use a class to create a specific instance of something, we create an object, and that object holds actual information. So we can think of a class as a category and an object as a concrete example of that category. Our chord object has several inlets and outlets shown as small blue slots at the top and bottom of the box. We use these to pass data into and out of the object, from and to other objects or functions in the patch. We can select an object and press the letter D to bring up its documentation page. This gives us a brief description of the object and explains the purpose of each inlet and outlet. The second inlet of our chord object, for example, is to input a list of pitches. The second outlet outputs a list of pitches the chord contains. These pitch values are represented as MIDI cents. In standard MIDI, pitch is represented using numbers from 0 to 127. Each number corresponds to a specific pitch, with each step representing one semitone. For example, MIDI note 60 is middle C, 61 is C sharp. MIDI cents are based on MIDI numbers, but offer much finer pitch resolution. Instead of limiting pitches to whole semitones, each semitone is divided into 100 parts called cents. This means that MIDI cents can represent microtones very precisely. So to convert a MIDI note number to MIDI cents, we multiply it by 100. We can double-click in an empty area of the patch to create a literal box. This is a general-purpose data input box that can contain numbers, lists, symbols, text strings, or expressions. We'll use it to create a list of MIDI cent values representing the pitches in a chord. In OpenMusic, lists are written using parentheses, with each item separated by a space. To create a chord containing middle C and a G a perfect fifth above, we need to multiply their MIDI note numbers 60 and 67 by 100. So we get 6,000 and 6,700. To connect this to our chord object, we can click on the outlet at the bottom of the literal box and drag a wire to the second inlet of the chord object, since this is the one that receives pitch information. We can preview the contents of the chord object by selecting it and pressing M. Currently, it only displays middle C, the default value of the chord object. Although we've connected our literal box containing the pitch list, we haven't actually sent the data into the chord object yet. This is an important principle in OpenMusic. Wires don't constantly send data. We need to explicitly evaluate the object to update it. To do this, we can select the chord object and press V. It now displays the correct pitches. Let's see how we can use a function to transform our chord. To transpose it, we need to add or subtract MIDI cents from its pitch values. If we go to the Functions menu, then navigate to Basic Tools, then Arithmetic, we'll find various functions for mathematical operations. We'll use OM+, which can be used for addition. If we already know the name of a class or function, we can instead double-click in the patch to create an empty box and then type the name directly. OM+ has two inlets, each of which will receive either a single number or a list of numbers. When evaluated, the values from the left and right inlets are added together. We'll connect the pitch outlet of our chord object to the first inlet of OM+. Since each semitone spans 100 MIDI cents, to transpose the chord up by one semitone, we must add 100 to its pitch values. To do this, we'll double-click to create another literal box, enter 100 and connect it to the second inlet of OM+. The function will add 100 to each value in the pitch list and output the results. We'll create another chord object and connect the output of OM+ to the second inlet to generate a transposed version of the chord. We'll preview it by pressing M and then hit V to evaluate. It displays our chord transposed one semitone higher. So in this patch, we've learned how to create a chord, input pitches in MIDI cents, and apply a function to transform it. The workflow of connecting objects and functions together is the foundation of OpenMusic. By combining different objects with different functions, we can perform many kinds of operations and transformations. In more complex patches, passing data between multiple objects lets us create much richer musical processes. Let me know if you'd like to see more videos about OpenMusic. Leave your feedback and suggestions in the comment section below. Please like and subscribe, and thank you for watching.